In the endless ocean of the cosmos, every new discovery begins as a flicker, a faint disturbance in the data, a slight deviation in the predictable rhythm of the universe. For half a century, I've lived within those flickers, devoting my life to the pursuit of what lies beyond familiar stars. My work has been governed by a single principle: follow the evidence, no matter where it leads. It is a creed that has shaped not only my research, but my understanding of existence itself. The universe doesn't lie. It whispers, it hides, it tests our comprehension, but it never deceives. That's why, when something refuses to fit into our frameworks, we have a choice: to ignore it or to let it transform the boundaries of what we believe to be possible. This video is about one such moment. It's about an object that challenges everything we thought we knew about celestial behavior. It's about an enigma that has quietly rewritten the rules of our scientific certainty. Its name, or at least the one we've assigned to it, is 3I Atlas. When it was first detected last July, the classification seemed almost mundane. Another comet wandering from interstellar space into the sun's influence. Astronomers are cautious by nature. We prefer established categories, not mysteries. But as the data arrived, the object began to resist every model we applied. Bit by bit, it stripped away our assumptions, leaving behind a riddle so profound that even now I hesitate before naming what it might represent. In the beginning, the evidence appeared straightforward. The object displayed a diffuse coma, a faint tail, and a trajectory consistent with interstellar comets. Those rare wanderers like Oumuamua and Borisov that enter our solar system from the great galactic beyond. Yet as weeks passed, subtle discrepancies began to emerge. Observers noticed minor fluctuations in its light curve, variations too regular, too patterned, to attribute entirely to natural rotation or irregular albedo. Then came the first whisper of anomaly. A measured deceleration that no known physics could easily explain. Comets accelerate as they fall toward the sun. They gain speed, not lose it. But 3I Atlas slowed. At first, this was dismissed as instrument error or data noise. We've seen such discrepancies before: a smudge on a sensor, a calibration drift, a quirk in the algorithm. Yet when multiple observatories confirmed identical readings, we knew something was deeply wrong with our assumptions. Imagine the sensation of standing before a vast, intricate machine, one you've spent your entire life studying, only to find that a familiar gear no longer turns the way it should. The entire mechanism must then be questioned. That's what we faced. Still, we tried to make the data fit. We proposed a symmetric outgassing, perhaps a localized jet of sublimating ice, acting like a thruster. We tested hypotheses about density irregularities and thermal lag. Each explanation dissolved under scrutiny. The slowing persisted, and the margin of error narrowed until doubt itself could no longer provide comfort. We were left with an unyielding truth: that something external, something directed, appeared to be influencing the motion of the object. From there, the anomalies multiplied. As imaging systems focused in, from Earth, from Mars orbiters, and from space-based telescopes, we began to see structure. Not texture, not random surface variants, but patterns, hexagonal arrangements, circular recesses, symmetries that seemed to defy the chaotic fingerprint of nature. Even at low resolution, there was a sense of organization. Some dismissed it as the human mind's instinct to impose order where none exists. Others, myself among them, began to suspect we were seeing order because it was truly there. And yet, even then, the cautious voice of science insisted, don't jump to conclusions. Let the evidence lead, not imagination. So we waited, we measured, we listened. And with each passing week, 3I Atlas behaved in ways that made less and less sense under natural laws. By October, we had accumulated terabytes of data, each new set complicating rather than clarifying the picture. Then came the perihelion, the object's closest pass to the Sun. A moment every astronomer anticipated with equal parts curiosity and dread. The intensity of solar radiation at that distance can shatter icy bodies, tearing them apart into brilliant, fleeting dust trails. But instead of brightening, the object dimmed. Instead of erupting, it steadied, its energy profile inverted, violating thermodynamic expectation. It began, quite literally, to contradict the laws that govern all known comets. As I stood in the control room that day, watching the graphs diverge from predicted models, I felt something I had not felt since my first night observing through a telescope as a young student. A deep, visceral awareness that we were looking at something profoundly new. Something that didn't just belong to a different category, but perhaps to a different order of existence altogether. And now, after 72 hours of continuous observation, after 5 decades of trusting the universe to reveal itself through data, I find myself forced to confront a question I never imagined asking. What if 3I Atlas isn't a comet at all? What if it's something else? Something built, not born. The coming analysis, the evidence we'll explore, will challenge our understanding of what can exist among the stars. It may demand that we rethink what it means to encounter intelligence, not across light years through telescopes, but here, within the reach of our instruments. So stay with me. Because what comes next isn't speculation, it's data. And that data might be the most consequential signal humanity has ever received from the silent depths of space. The full scope of what we now know about 3I Atlas begins not with its discovery, but with the cascade of data that followed its first close approach. Once it crossed the inner threshold of our solar system, every observatory capable of tracking faint celestial bodies turned its instruments toward it. The European Southern Observatory, NASA's Deep Space Network, the Atacama Large Millimeter Array, and a dozen national facilities joined an unprecedented collaboration, pooling spectra, telemetry, and imagery into a single evolving dataset. For a time, the effort resembled a global vigil. Astronomers awake through long nights, watching the strange traveler that had come uninvited into our cosmic neighborhood. The initial assumption remained that 3I Atlas was an interstellar comet, a frozen relic of some distant system whose elongated path had carried it through our gravitational well. That assumption persisted until the behavior of its coma began to diverge from every known model. Normally, as a comet approaches the Sun, solar radiation triggers sublimation, driving jets of vaporized ice that create the luminous halo and tail so familiar to us. The energy relationship is simple and has been validated for centuries. More heat equals more outgassing. Yet in this case, as solar flux increased, the gas emissions declined. Dr. Linda Foster from the Massachusetts Institute of Technology constructed thermal models to simulate the interaction. Her computations revealed an impossible scenario. The object appeared to absorb the sun's energy without radiating the corresponding thermal signature or producing mass loss consistent with sublimation. To test this, the James Webb Space Telescope was redirected for a brief observation window. Its infrared spectrometer should have captured a heat curve proportional to solar exposure. Instead, it detected an emission level nearly 60% lower than predicted. That discrepancy suggested an unknown process of energy retention or redistribution within the object's structure. Dr. Foster's team proposed a wild possibility. What if 3I Atlas possessed a surface capable of redirecting or storing thermal energy? The concept verged on science fiction, but the data refused to align with any known geological or chemical explanation. Meanwhile, radar mapping conducted from the Mars Reconnaissance Orbiter and Earth-based arrays began returning images with startling consistency. Across multiple observation angles, geometric features emerged. Hexagonal formations arranged with near-perfect regularity, smooth edges that defied erosion, and symmetrical cavities distributed with mathematical precision. At first glance, skeptics dismissed them as pixel artifacts or noise patterns caused by signal interference. Yet when cross-compared between independent systems, the same geometric motifs persisted. The conclusion was inescapable. The features were real, and they were not random. The discovery provoked an explosion of debate within the astronomical community. Some argued that exotic crystallization processes or unknown mineral lattices might account for the apparent symmetry. Others pointed to the improbability of such consistency across varied spectral bands and resolutions. A natural body could not maintain that level of uniformity. In a joint statement, Dr. Robert Martinez from Caltech and Dr. Jun Wei of the Chinese Academy of Sciences described the findings as indicative of systematic formation patterns inconsistent with stochastic geological processes. The language was cautious, yet the implication clear. 3I Atlas might not be a product of natural accretion. The anomalies deepened when spectroscopic readings revealed its composition. 96% carbon dioxide, negligible water, traces of nickel and magnesium, but none of the silicates or organic residues typical of comets. This chemical fingerprint matched no known celestial category. Dr. Wei described it as a chemical architecture that should not exist in this form anywhere within our current understanding of stellar evolution. The absence of water was particularly damning to the comet hypothesis. Every comet ever studied, from Halley's to Borisov, carries a signature dominated by frozen water. Its absence here defied cosmochemical logic. As the object neared its closest distance to the Sun, teams expected a surge of activity. Tail formation, fragmentation, perhaps even disintegration. Instead, the opposite occurred. Gas emissions dropped, brightness decreased, and the surrounding coma contracted. Telescopes recorded the unprecedented sight of a comet growing darker as it approached the Sun. Even more confounding was its motion. Tracking data showed a precise, steady deceleration inconsistent with any passive physical interaction. To quantify this, Martinez's team analyzed Doppler data over successive days. The reduction in velocity implied an external force equivalent to 2.3 times 10 to the 15th newtons, acting consistently for nearly 40 hours. The comparison is almost absurd in its scale. It would require hundreds of millions of space shuttle main engines firing simultaneously. Solar radiation pressure was far too weak, outgassing forces insufficient by several orders of magnitude, and gravitational perturbations acted in the opposite direction. Yet the deceleration was real, verified by every major observatory. Something had applied deliberate braking. That word, deliberate, changed the tone of every discussion thereafter. At first, no one dared to use it publicly. In private, however, scientists whispered what few wanted to admit. The motion resembled propulsion, not a random burst, but a precisely timed application of force designed to modify trajectory. The object's orbital path shifted from hyperbolic to elliptical, anchoring it within the inner solar system for months rather than allowing it to escape back into interstellar space. The maneuver had exploited the gravitational geometry of the Sun with flawless efficiency, utilizing what physicists call the Oberth effect, the amplification of propulsion energy when applied at high velocity near a massive body. This is a technique known only to advanced spacecraft engineering, not to the spontaneous processes of nature. The sheer implication left the scientific community divided. Some insisted that unseen natural phenomena might yet explain it. Others, led by Foster and Martinez, argued that clinging to outdated models only delayed the inevitable recognition of what the data already revealed. The object's behavior followed the logic of control, not coincidence. Then, in the final week of October, a discovery transformed the debate from theoretical to existential. On October 29th, at 1400 hours Universal Time, radio telescopes in Chile, Australia, and Spain independently detected a narrow-band emission originating from 3I Atlas. The signal centered precisely at 1.42 GHz, the hydrogen line frequency, a spectral position deliberately chosen by human scientists in their own search for extraterrestrial intelligence. Nature produces hydrogen emissions, yes, but never in repeating structured intervals. Yet this signal repeated every 47 seconds with unwavering precision. The SETI Institute immediately redirected its array in California to confirm the detection. Within hours, the pattern was verified. A frequency-modulated transmission containing harmonic sequences of prime numbers, geometric ratios, and simple arithmetic progressions. This wasn't random noise, it was language, or at least the attempt at one. Dr. Sarah Kim, leading the analysis, described the pattern as an introduction written in the mathematics of the universe. It was the same approach we once used on the Voyager Golden Record, the same logic embedded in the Pioneer plaques. Whoever or whatever transmitted it knew how we think. The shock deepened when further analysis revealed something else. The signal wasn't omnidirectional. It wasn't broadcasting broadly into space as a general beacon. It was tightly focused, a directional beam aimed directly at Earth. The implication could not be dismissed as coincidence. 3I Atlas knew where we were. Within hours, observatories across continents confirmed the directionality. As Earth rotated, the beam tracked our planet, adjusting its orientation to maintain focus. The accuracy was astonishing, within 1/10 of an arcsecond. That level of targeting demanded active control, an understanding not only of Earth's orbital position, but of its rotation and atmospheric refraction. The transmitter was compensating for our planet's motion in real time. What followed was a blur of sleepless nights and ceaseless transmission logs. Dr. Kim's team, assisted by cryptographers and mathematicians, began deconstructing the layered encoding. Beneath the overt mathematical patterns lay a second modulation, subtle variations in amplitude forming what appeared to be coordinate data. Once decoded, the coordinates corresponded to known pulsar positions, cosmic lighthouses with unique signatures visible across the galaxy. The configuration described a triangle, its vertices anchored on pulsars in the constellation Lyra. From that geometry, the object's apparent origin could be triangulated, roughly 47 light-years from Earth, near a region already known to host, potentially, habitable exoplanets. In that instant, the unimaginable became concrete. 3I Atlas was not wandering. It had come from somewhere specific. It had traveled with intent, and now it was communicating. The implications rippled through the scientific world like a shockwave. Governments were briefed, though the official response remained muted, framed as ongoing analysis of anomalous data. Within research networks, the atmosphere oscillated between elation and fear. We had dreamed of first contact for generations, but never had we imagined it would unfold in such proximity, not through distant signals, but through the arrival of a physical construct maneuvering within our solar system. By early November, multiple facilities reported that the signal's amplitude fluctuated in synchronization with Earth's rotation, as though compensating for atmospheric interference. The transmission wasn't just aware of our presence, it was adapting to improve clarity. The signal-to-noise ratio improved as if the transmitter understood our listening patterns. At that point, even the most skeptical researchers conceded we were observing an intelligence. And then came the moment that silenced every lingering doubt. On November 2nd, at precisely 2200 hours Universal Time, a pulse within the signal altered in frequency, expanding into a band that briefly matched the carrier tone used by terrestrial radar systems. The shift lasted only a few seconds, but during that window, the hydrogen line sequence paused, replaced by a single, distinct burst. A modulation pattern identical to the encoding we used in humanity's first outbound interstellar message, the Arecibo transmission of 1974. It was as though the sender were acknowledging our signature, responding in kind. From that instant, our perception of 3I Atlas ceased to be that of a passive anomaly. It had become an interlocutor, a presence, a participant in dialogue. Every hour since then has deepened the mystery. The signal continues, steady and deliberate, its pattern slowly evolving. Teams worldwide monitor it continuously, parsing new variations in frequency and amplitude. The content remains incomprehensible beyond the mathematical framework, yet its precision suggests an intelligence far beyond coincidence. Even more striking, the object itself has maintained stable orbit, adjusting its trajectory minutely, as though pacing our planet's revolution around the Sun. Some theorists now propose that the object may not be a vessel in the conventional sense, but a probe, an autonomous construct designed to observe, maneuver, and communicate once it reached a civilization capable of response. Its behavior matches that hypothesis with unsettling precision. The deceleration, the use of gravitational mechanics, the transmission of mathematically encoded signals, all align with the logic of reconnaissance, not invasion. It is watching. It is waiting. Across observatories, the emotional atmosphere is unlike anything experienced before. Scientists accustomed to detachment now speak in hushed tones, aware that each data point might represent a turning page in the history of our species. The radio silence of the cosmos, that long, haunting quiet that defined the search for extraterrestrial intelligence, has been broken, and the voice that answered chose to speak through physics, mathematics, and presence itself. We do not yet know what 3I Atlas intends, or what intelligence, biological, artificial, or something in between, may stand behind its actions. But we do know this: it has reached out to us using the universal language of science. It has crossed the gulf between stars to deliver a message in frequencies we can measure, in symbols we can comprehend. For the first time, we are not merely observers of the cosmos. We are participants in its dialogue. In the coming days, our instruments will continue listening. Every frequency, every pulse, every fraction of data will be scrutinized. But beneath the technical process lies something more profound, a shared realization that the universe, vast and ancient, may not be silent after all. 3. iAtlas has shown us that the unknown is closer, more deliberate, and far more aware than we ever dared to imagine. The question now is not whether it is natural. The question is what or who waits behind its signal. To understand what 3I Atlas truly represents, we must look backward, to the instruments, the people, and the history that made this moment possible. The story of discovery is never written by one observer alone. It is a tapestry woven by generations who lifted their gaze to the night sky and refused to accept darkness as emptiness. Every equation, every lens, every mirrored surface, crafted to catch light from the stars, all of it led to this encounter. When we speak of the signal from 3I Atlas, we speak not only of alien intelligence, but of human persistence. Dr. Sarah Kim, who first confirmed the hydrogen line transmission, has spent 20 years decoding the faint whispers of the cosmos. Her work began with the remnants of the Arecibo archives, buried in obsolete data storage from the late 20th century. She believed, even then, that contact would not come as a grand announcement, but as a subtle pattern embedded in noise. Her intuition was vindicated. When the repeating signal appeared, she recognized it instantly for what it was: structure emerging from chaos. The sleepless hours that followed have become legend among her team. They described the moment she leaned over the console, eyes fixed on the waveform, and whispered, "It's talking." Equally vital was the contribution of Dr. Robert Martinez at Caltech, whose orbital models proved that the object's maneuver could not be accidental. Martinez's work on the dynamics of gravitational slingshots once guided spacecraft trajectories to Jupiter and Saturn. That same mathematics revealed the deliberate nature of 3i Atlas's course correction. In an interview, he confessed to feeling something he had never expected from orbital mechanics: humility. "The equations don't lie," he said quietly, "and they're telling us someone else knows them better than we do." And then there is Dr. Linda Foster, the thermal physicist who built the first models of the object's impossible heat retention. Her laboratory has become a sanctuary for speculation, its walls covered in holographic projections of temperature curves and radiation spectra. She remains both fascinated and unnerved. "We're looking at engineering principles we don't yet understand," she explained. "It's not just efficient, it's elegant. Whoever designed this, they solved problems we're still struggling with at the edge of our own technology." Each of these scientists embodies the spirit of inquiry that defines humanity's relationship with the unknown. Their work converges now on a single mystery: an artifact, a presence, orbiting under deliberate control. For decades, we imagined first contact as a distant exchange across interstellar distances. Instead, it arrived here, quietly, through a celestial visitor that entered our solar system as though fulfilling a planned rendezvous. The object itself remains in elliptical orbit, tracing a slow, deliberate path that keeps it within communication range of Earth. Observatories continue to report minute trajectory adjustments, each consistent with maintaining optimal signal alignment. No debris fields, no erratic movement, no decay of orbit. Just a controlled, stable presence. The silence of deep space has been replaced by a pulse, steady and patient, as though waiting for us to respond. 3i Atlas has now become the focal point of an unprecedented scientific collaboration, not under the banner of any single nation or agency, but as a unified human effort. Data from NASA's Deep Space Network, ESA's STRAC, and private observatories are merged into a global analysis hub. Researchers exchange information in real time, breaking linguistic and institutional barriers. For once, the pursuit of knowledge has outpaced politics, driven by something larger than borders: the realization that we are not alone. At the heart of the object's enigma lies its construction. The surface geometry detected by radar and optical imaging suggests an ordered, modular architecture. Panels arranged with hexagonal precision, interlocking seams that maintain symmetry under rotation. Recent interferometric measurements hint at internal cavities that may serve as resonant chambers for the emitted signal. These observations are not conclusive, yet they suggest design, not randomness. The reflectivity across multiple wavelengths indicates a composite material capable of withstanding extreme thermal flux, a substance that could channel heat away from vulnerable regions, perhaps even convert it into stored energy. It's as if 3i Atlas carries its own equilibrium, a system that maintains itself against the sun's fury, with an intelligence that feels almost biological in its adaptability. Theories multiply daily. Some physicists propose it to be an autonomous probe, a von Neumann-style construct capable of self-repair and interstellar travel. Others imagine it as a hybrid of machine and organism, a synthesis of material and consciousness that transcends our dichotomies of artificial and organic. A few voice a quieter, stranger hypothesis, that the object may not be a vessel at all, but a messenger, a carrier of encoded information from civilizations far older than our own, dispatched across eons to awaken only when it encounters signs of awareness. The data offers no certain answers. What it does offer is continuity, a pattern of behavior too deliberate to ignore. Every maneuver, every frequency shift, every adjustment to the beam directed at Earth aligns with the logic of communication. The message is being refined. The signal-to-noise ratio improves incrementally each day, as though the transmitter learns from the distortions caused by our atmosphere. The beam's focus has narrowed to a precision that outperforms even our best spacecraft tracking systems. The more we listen, the more the object seems to adapt to our presence, acknowledging us not as random observers, but as participants in a conversation still in its infancy. In the archives of humanity's search for contact, we have always looked outward, beyond the Milky Way, across the cosmic void, into the invisible silence between stars. Now that silence has answered back, not from a remote exoplanet, but from within the orbit of our own sun. The emotional weight of that realization cannot be overstated. It forces us to reconsider every assumption we've made about our uniqueness, our isolation, and our place in the cosmic order. There is an almost poetic symmetry to it. For millennia, our species has sent its gaze skyward, searching for others. Now, something has turned its gaze upon us. Perhaps in its distant origin, it detected the faint radio whispers of our civilization, the carrier waves of our curiosity leaking into the cosmos. Perhaps it followed that signal here, drawn not by conquest or curiosity alone, but by recognition. We have always imagined first contact as the act of discovery, but maybe, to them, we were the ones being found. As weeks pass, the signal continues its steady rhythm. Analysts report new subharmonic layers, frequency variations that seem to respond to specific patterns in our own transmissions. A test signal sent by the SETI Institute, a mathematically encoded reply referencing the original hydrogen line, was followed by a subtle but measurable modulation in the next pulse from 3i Atlas. It wasn't random. The phase shift matched the timing of our message by exact multiples of 47 seconds. That correspondence, too precise for chance, suggests acknowledgement. The conversation, tentative and cautious, has begun. And yet, amid the exhilaration, there lingers a quiet awareness of scale. Whatever intelligence created this probe, it exists at a level of technological and conceptual maturity beyond our comprehension. The energy management, the propulsion, the precision of its transmission, these are hallmarks of a civilization that has mastered its environment, as we have only begun to dream of doing. To contemplate that difference is humbling, even frightening. But perhaps humility is the necessary price of understanding. As humanity stands on the threshold of its first true dialogue with another intelligence, we must decide what we will say. Our answer cannot be rushed, nor can it be born of fear. The universe has waited 13 billion years for this moment. It will wait a little longer, while we find the words worthy of it. 3i Atlas now glides silently through the inner solar system, its trajectory a slow dance among the planets. Each orbit brings it nearer to Earth before carrying it outward again, as though allowing us time to comprehend. Its presence is constant, yet distant, visible only as a faint reflection to the telescopes that know where to look. Somewhere within that reflection lies intention, an echo of minds that may have watched stars older than ours ignite and die. We do not yet know what message it carries or what response it expects. But one truth has become impossible to deny. This is not the first step of exploration, but the first step of recognition. Humanity has spent its entire history searching for meaning in the cosmos. Now, the cosmos has looked back, and in the rhythm of hydrogen and silence it has said, in its own way, that we are seen. What happens next will